Okay, so we're going to try question number 5. Okay, just the stuff we've been doing. This is another one that is an exam level question. It's the kind I would put on a unit exam. Okay. Okay, so if we're looking at our diagram here, we got 200 meters due east. Okay, and then our next vector is 30 degrees west of north. So I'm going to draw a reference line, okay, that is due north and go 30 degrees west of that, 135 meters. Okay, so this will be 30 degrees west of north. That will be 135 meters. Scales pretty close. Okay, that'll be X, that'll be Y, and my resultant will look like that. Now, for this resultant, you can draw the triangle either way. I'm going to draw mine this way. You can draw yours inside if you want, that's fine. Okay, that's what the diagram should look like. Think about 4 or 5 years ago, that was what the exam would look like. Okay. Like I say, it's exactly like what I would ask you on the exam, except I think it was 30 degrees north of west. Pretty much the same thing. Okay, so for this one here, okay, we want to find all of our x's and y's. Okay, the x component for our 200 meter vector is 200 meters east. And its y component is 0 meters because it doesn't go north or south, right? It's not a triangle, it's a horizontal line. Okay, and if we're looking for blue x, okay, blue x is going to be the opposite side to our 30 degree angle, right? So we're going to have the sine of 30 times 135, which should be 67.5 meters, and that's going to be west. Okay, and then y is going to be the adjacent side, so it'll be the cos of 30 times 135. Calculator's not starting. So cos of 30 times 135 is going to give me 116.91 meters north. Okay, so now that we've got those, what's my next step?
For your x, you can go 200 minus 67.5, so you can find your red x.
Yeah, exactly. I've got to get red x and red y by adding my x components and adding my y components, or subtracting, okay, whichever. So for red x, I've got 200 meters east, okay, and I've got 67.5 meters west. Right. So when I do that, I should get 132.5. Yes. Okay, 132.5 meters east. Okay, and for my y component, well, since black y is 0, the only time I go north or south is on blue y. So blue y and red y are the same number. Okay, so they are going to be 116.91 meters north. All right, so now I know this one, and I know this one. Now, if I'm looking at my diagram right now, my scale's not terrible, okay? But it's not perfect either. My 132.5 line and my 116.91 line are pretty close to the same length, and they really shouldn't be. But did it mislead me at all? it's still generally pointing in the right direction. Okay? All right, so now that I've got those two numbers, can I find D? Yes, so now I do Pythagorean theorem. Okay, so we'll have our 116.91 squared plus our 132.5 squared to get us the magnitude of our displacement. So. All right, so we're looking at 176.71 meters, and then we've got to find our angle as well. Okay, so theta, depending on which way you drew the triangle, is going to be 10 to the minus 1, or any trig function you want because you know all three sides now. Okay, for me, 132.5 over 116.91. All right, so I'm looking at 48.58 degrees. And for me, that is going to be east of north. Okay, how many significant digits did my answer have? 2. Sorry, Tony, question?
I was gonna ask, how are you supposed to know whether to say north of east or east of north?
Okay, so what I do is I look at my angle arc, and that is my second direction. Whatever main compass direction it touches, that's where I'm going from or of, and I'm moving east of that.
Right.
Yeah, does that make sense? All right, so I've got 2 significant digits, so I'm going to be looking at an answer here of 1.8 times 10 to the 2 meters at 49 degrees east of north, or at 41 degrees north of east, if you drew the triangle the other way.
Do you have to do, when you're finding for blue Y, do you have to use cos?
How else would I?
No, because I use sine and I got 1 decimal or 1 digit off of your answer. So is it because I use sine?
How did you use sine to get y?
I did 67.5 divided by sine 30.
67.5 divided by the sine of 30 should give you 135.
No, because it gave me 117.7.
So you said 67.5
Yeah,
divided by the sine of 30.
Oh, sine of 35. Because that was the angle it gave us. So I meant to say sine of 35. Oh, it gave us 30. Never mind.
Yeah, so I think, wow, incredibly lucky. Yeah, that just happened to work that way. But no, we got to use cos. The only other way, and I don't recommend doing this, is to do Pythagorean theorem in reverse. But you don't always get as many decimals or is quite as accurate because it rounds off, whereas trig doesn't. Yeah. Okay, how are we feeling about this? Okay, we're starting to kind of get the hang of it. Because I mean, I don't want to beat you over the head with it, but I also want to make sure you are confident in it. What I'm seeing right now is that you guys have a pretty good grasp of how to do it. But we haven't done enough to kind of get our speed up on them. Okay? It's good that we know how to do them, we can consistently do them, but it's also important for a question like that to take us less than 10 minutes. Okay, and by less than 10, I mean like we should be able to do it in 6 or 7 minutes probably. Okay, and that just comes with practice. Once we know the steps, okay, we should be able to effectively do those. Okay, one more. This one would be as tricky as I would give you. And that's because it completely, well not completely because then it would be collinear, but backtracks on itself.
Is it X and Y?
Yep.
Instead of Y, you're supposed to use sine, and X, you're supposed to use cos. Because
No, it just so happened that the first few we did, X was always the adjacent side. And so on this one here, X happened to be the opposite side, so I use sine. There's no hard and fast rule for that. It's
Okay.
wherever it goes, use the appropriate one. Yes. Okay, so that one, the diagram is important, okay? And scale is important on that one. Okay, guys, let's look at the diagram for this one here. Okay, so we got 250 kilometers at 30 degrees north of west. Okay, so I'm going to go west, and then I'm going to go 30 degrees north of that. No, that's probably close to 30 degrees. Okay, so that'll be Y, that'll be X, that'll be my 30-degree angle, and that'll be 250 kilometers. Okay, and then I've got to go 75 degrees south of east. Okay, so there's east. I drew that way too long because I'm going to go 75 degrees south of that. Okay, for 123 kilometers. So what I have to do is I kind of have to look at my scale here, right? Like I've got 250 kilometers here for that length, and then I'm going to draw a line that's going to be half that long, so only about this long here. Okay, everybody with me? Scale is going to be really important because I'm going almost straight down. Well, it's going to be a little bit angled, but okay, I would say that angle would be 75 degrees south of east. Okay, so this would be X, this would be Y, and that would be 123 degrees. Okay, or sorry, 123 kilometers, sorry. Right, I could have maybe made it a little bit longer, but I'm pretty sure it's not going to get down below the first one, okay, at that length. All right. That means then that our resultant is going to go from here to there. And it's going to have a pretty narrow triangle. Okay, so that's a tricky diagram. It's really easy to mess that diagram up and go either way too far downwards on the second vector or not make the second vector long enough and be too far up. Okay, that one's being too far up is better than being too far down because then at least it's not really lying to you. But if you draw it too long, you're going to get south of west instead of north of west, and it's going to look really wrong. Okay, everyone with me on that one? For how many people was the diagram really tricky and maybe they're like, oh man, now I'm not. And that's okay. This is a tricky diagram. Okay, like the first time I drew this, I did that too. I went down to here with that line. And then I did all the math and went, oh, wait a minute, my diagram's wrong. And I had to go back and start the diagram over. Didn't have to start the math over. The math was right, okay? But you have to trust it. Okay, I'll give you a few more minutes to get ahead of me here and then we'll walk through the rest of that one. Okay, so Ty brings up a good point. This is very busy, this diagram, and it can become overwhelming. Okay, so it is absolutely okay to use what we often refer to as the separate triangle method. Okay, the separate triangle method is mathematically identical to this method. The diagram is different. The diagram and the separate triangle method have only one flaw. And that is that you don't see the full picture with the separate triangle method because you can't build your resultant's triangle, which is the green one here, until you've done all the math. Okay, does that sort of make sense? So if I drew this all separately, okay, and I had my 250, and so I could draw this one here, it was 30 degrees, it was 250 kilometers. Right, this was Y, this was X, and then I draw the red one, but I don't draw it on the head of this one. I just do this and say, all right, it's going to go degrees, this was x, this was y, and this was 123 kilometers. Now, scale doesn't matter, because I'm not putting them together. But I also don't know what my resultant looks like. And I don't know what it looks like until I find out red x, red y, purple x, purple y, and then do all the math. Then I can build my resultant triangle from the math. That's good or bad, it depends on how you look at it. Okay? For me, I'm a big picture person. I like to see the big picture right away and see if my math agrees with it. But sometimes people are like, it's just too much. I'm overwhelmed by looking at this. I want to do it this way and build my triangle later. Totally fine. Like I said, the math isn't any different. You're going to get the same answer regardless of which way you do it, and you're not going to lose marks for using the separate triangle method. Okay? It's equally valid. All right? So, looking at the rest of said math here. All right, so for the purple triangle, okay, so why does it keep doing that? I clearly pressed there. All right, so purple x is going to be the cos of 30 degrees times 250. All right, so we got 216.506 kilometers west. Okay, purple y is going to be the sine of 30 times 250, which is 125 kilometers north. Okay, and then for our red triangle, okay, red x is also adjacent, so that'll be the cos of 75 degrees times 123. Okay, so 31.835 kilometers east. Okay, red y will be the sine of 75 degrees times 123. 118.809 kilometers south. Okay, so now that I've got all of those, if I was using the separate triangle method, okay, now I would want to get what green, well, either way, I want to get what green x and green y are. All right, so to get green x, okay, I'm going to take purple x, which was 216, I'm going to subtract the 31.835. Okay, so my resultant's x component is going to be 184.672. kilometers, and that is west, because I subtracted east from west and I still got a positive number. Okay, and then for y, okay, they're also going to be subtracted because they're in different directions. So I'm going to take the 125 and subtract the 118. All right, 6.19, that's pretty small. Kilometers, and that is north. Okay, so if I'm doing the separate triangle method, now I can build my resultant's triangle. Okay, and so the advantage here is that in a tricky draw like this, I don't have to worry about having drawn everything the right length. I know now what my triangle should look like, and I go, all right, 184 kilometers here, and I go like that, and I make this incredibly narrow resultant triangle, and it's 6.19 here, and there it is. Now I can find it. I mean, it looks similar to the one I drew, and it still points the same direction. I still get the same answer either way. All right, so now that I've got the parts of that resultant's triangle, now I can find my displacement's magnitude. So that'll be 6.19 squared plus 184 squared. squared, obviously with all the decimals in your calculator, not the shortcut that I just did. Okay, so I get 184.78, okay? Kilometers, and then to find theta, I'm gonna take my triangle, so y was the opposite side, so I'll go tan to the minus 1 of 6.19 divided by 184, so it's gonna be a really, really, really small angle, okay, because the opposite side is very small compared to the adjacent side. And I get 1.92 degrees. And for me, that's going to be north of west, the way I drew the triangle. So for this question, I have two significant digits, right? So my final answer is going to be 185 meters, kilometers, at 1.9 degrees north of west, or at 88 degrees west of north if the triangle ended up the other way.
So when you're doing significant digits for your final answer, do you look at the degree as a separate unit and then?
Whoops, sorry. Yeah, no, I see what you're saying. This should be right, two significant digits, right? Sorry, no, it should just be 1.8. It should just be 1.8. Sorry. 1.8.
So everything will.
Everything has the same, yeah. And that's why, like here, this has 2. It looks more accurate because it has a decimal, but they both have 2 significant digits. Okay, that's about as tricky as they would get unless I was to give you one that was like, 5 vectors, which there is one on your vector addition worksheet, and it has to do with the Raiders of the Lost Ark. If anyone's ever seen that movie, Harrison Ford is Indiana Jones before he became a decrepit monkey skeleton. Yeah, because now he's actually going to be Indiana Jones again, and he's like 80. Just seems somewhat less impressive to see an 80-year-old guy do like a bolo punch, kind of thing. Okay, for moving forward here, guys, we're going to do map activity when we get back from the break. Okay, just kind of bring back to vectors a little bit. Then we'll do probably one more day of vectors. I'll pick some stuff from the worksheet just to refresh our memory. Then we'll do an assignment on vectors, and then we'll be done with vectors. We'll move on to projectile motion, okay, and that'll take us about a week, and then we'll have the unit exam. All right, so it's coming up probably 2 weeks from the Monday we get back. Is around where that's going to fall. Okay, but I'll let you know what day exactly when we get back from the break. Okay. You still got a few minutes if you want to talk to your group mates about your acceleration lab, maybe get a couple of things done, not maybe have it for homework so much. Because that's due, obviously, when you come back on the Tuesday.